4,000 times the mass of the Sun and wider than the entire Earth. These black holes might have become the seeds for supermassive black holes. So now we arrive at the kings of our universe.
And again, I don't understand how they know all this. What is blowing my mind? How they know this? I don't understand. Hello, my dear friends. Hello. My name is Alex and I study English, and today we will watch another video. And this video was recommended me by Michael Halim. Thank you very much for your recommendation, Michael. Thank you. And also, you wanted me to watch this video, Spy Dodge. Thank you very much. And yes, this video will be very exciting because this video will be about universe. I know it will be very useful for me, and I hope what for you it will be very interesting too. Okay, this video is named The Largest Black Hole in the Universe, Size Comparison. Yeah. And of course I will leave link below from original video. Of course I will leave link, and I will leave link from my Patreon. You can be my Patreon too. Patrons. And also you can support me, leave a like and subscribe to me. For me it means really a lot. Okay, let's continue. Let's watch. I remember this word. And of course, I want to see, have we here, oh, yeah, we have here Google Translate. Let's go.
Different kinds of black holes.
Oh, what I am doing?
The largest things in the universe are black holes. In contrast to things like planets or stars, they have no physical size limit and can literally grow endlessly. Although in reality, specific things need to happen to create different kinds of black holes, from really tiny ones to the largest single things in the universe. So how do black holes grow? And how large is the largest of them all?
I remember this channel. I watched from this channel before videos, and I watched from your recommendation, Michael Halim. Am I right? Yeah, I think I'm right.
This video will not discuss how black holes work or how they form, since we've looked at that in detail in our black hole and neutron star series. You can check them out afterwards. For now, we're interested in finding the largest thing in the universe. Let's start really small. Primordial black holes. The smallest kind of black holes may or may not exist. If they do, they're probably the oldest objects in the universe, older even than atoms.
How it's possible? They even don't know exist such a black holes or not. I think it's just a theory. How it's named? Hypothesis. One moment. Am I right? Hypothesis. Oh. I was using Russian language.
Hypothesis.
Hypothesis. I think it's just hypothesis. Yeah.
Atoms. They would have formed just after the Big Bang, when the universe was so dense with violent energy that any tiny pocket that was...
Again, I don't know this word. Dense. Was so dense. I know dance. Dance? And this dance. Oh, I get it.
Dense.
It's really logical what this word here in this video.
The universe was so dense with violent energy that any tiny pocket that was just slightly more dense than its neighbors could produce a black hole. The smallest primordial black hole that could still be around would be 8 trillion kilograms or so, the mass of a big mountain. And yet they would be no bigger than a proton. A primordial black hole with the mass of Earth
Oh my god!
would barely be larger than a coin. This makes them very hard to find, so we haven't actually observed any yet. If they exist, they may even be the mysterious dark matter that holds galaxies together. Let's move on to the kinds of black holes that we know for sure are out there.
Stellar black holes. Maybe I will find them, how they looks. Stellar black holes. Wow, I like it. Wow, it's look very beautiful.
Stellar black holes. To make a black hole, we need to compress enough matter so that it collapses into itself. After that, the more mass we throw at it, the larger it becomes. In today's universe, only the most violent cosmic events can create the necessary conditions, such as the merger of neutron stars or when the core of a very massive star collapses in a supernova. To have a unit to work with here, we'll use the mass of our Sun, about 2 million trillion kilograms. The smallest known black hole has 2.7 times the mass of the Sun, which works out as a sphere around 16 kilometers in diameter, large enough to cover Paris. Another lightweight black hole is the companion to the V723 Mon red giant star. This star is 24 times larger than our Sun, 30 million kilometers in diameter. And yet, it's thrown around by a tiny black hole just 17.2 kilometers wide. This tiny thing bullying the star is so much smaller that we can barely even show them in comparison. One of the largest known stellar black holes is M33X7. It currently spends its time eating a 70 solar mass blue giant bit by bit. As all that stolen matter circles towards the black hole, like water going down a drain, friction heats it up to temperatures high enough to shine 500,000 times brighter than our Sun. And yet, X7 is only 15.65 solar masses and 92 kilometers wide, just big enough to cast a shadow on Corsica.
And for me, it's interesting to know if black holes. One moment, I want to read a little. One moment. I want to read black holes. Oh, yeah, black holes. Definition. Short definition. It is a space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light can escape from it. And for me it's interesting, even the light cannot escape from black holes. But how scientists can find them? Which tools, what they are using for this? Yeah, for me it will be interesting to know your explanation, because I don't know this. Yeah, I don't know. Okay, how they can find them if even light here useless?
To grow much larger, black holes have to either devour a lot of stars or, better, merge with one another. The instruments that make it possible to detect these mergers are very new, so we're currently discovering a lot of exciting things. Like 2 massive black holes that we detected in a galaxy 17 billion light-years away. As they spun around each other violently, they released more energy in the form of gravitational waves than the combined light from all the stars in the Milky Way in 4,400 years. The new black hole they formed is about the size of Germany and is 142 solar masses. And here we hit a curious gap in scale. There are
Gap in scale. Gap, I know. Gap in Scale. Scale. I think I get it. I hope so.
There are lots of black holes up to 150 solar masses, and then there's nothing for a long time. Until we suddenly hit black holes that are millions of times more massive. Which is a bit confusing because we had this idea that black holes are consistently growing and growing. But for the most massive black holes, this process is not fast enough to explain their existence today. The universe is simply not old enough for these supermassive black holes to have formed by eating stars and merging with each other. Something else must have happened. To explain how we got the largest black holes in the universe, we might need the largest stars that ever existed, quasi-stars. To get a sense of scale, we can compare them to the largest stars that exist today. Our Sun is like a grain of sand next to them. We don't know if quasi-stars actually existed, but they're an interesting concept when it comes to supercharging black hole development. The idea is that the matter in the early universe was so dense that quasi-stars could grow to thousands of times the mass of our Sun. The cores of these stars might have been crushed by their own weight so much to actually collapse into black holes while the star was still forming. In contrast to stars today that would destroy themselves in the process, inside quasi-stars, a deadly balance could emerge. Gravity pressed the supermassive star together, feeding the black hole and heating the material falling in to such a degree that the radiation pressure kept the star stable. And so these quickly growing black holes might have been able to consume the quasi-star for millions.
To consume. One moment. Yeah. Yeah, I get it. To consume, of course. Consume.
Of years and grow far bigger than any modern stellar black hole. Black holes several thousand times the mass of the Sun and wider than the entire Earth. These black holes might have become the seeds for supermassive black holes. So now we arrive at the kings of our universe.
And again, I don't understand how they know all this. What it's blowing my mind. How they know this? I don't understand. Maybe if I will spend thousands of hours with science and will study this every day for during 9 hours per day, of course I will understand it after maybe a few years. But at first, now, at this moment, for me it's really mind-blowing. It's something impossible. And for me it's even difficult to imagine. Yeah.
The largest single bodies in existence. The centers of most galaxies contain a supermassive black hole, and they are monstrous. In the Milky Way, we have Sagittarius A star, a supermassive black hole with about 4 million solar masses that is calm and collected and just does its thing. We know it sits there because we can see a number of stars being thrown around by a seemingly empty spot. And despite its
A seemingly empty spot.
Oh,
one. I wanted to see subtitles. Seemingly. Oh, I know. Seemingly. But this is seemingly. Of course, I know. I know this. Seemingly. Empty spot. I get it.
Spot. And despite its incredible mass, its radius is still only 17 times our Sun. Smaller than most giant stars, but millions of times more massive. Because supermassive black holes are so massive and located at the center of galaxies, many people imagine them as being a bit like the Sun in the solar system, an anchor that glues everything else together and forces it into an orbit. But this is a misconception. While the Sun makes up 99.86% of all the mass in the solar system, supermassive black holes usually only have 0.001% of the mass of their galaxy. The billions of stars in galaxies are not gravitationally bound to them. Instead, it's the gravitational effect of dark matter which holds them together. Many supermassive black holes aren't gentle giants, especially when they're feeding on the clouds of mass in their galaxy. The one at the center of the BL Lacerti galaxy is devouring so much material that it produces jets of plasma accelerated to nearly the speed of light.
Black matter, it is, you can't touch it, yeah? Am I right? It's like electromagnetic. And it can hold all these billion stars. It sounds really crazy.
If Earth were orbiting this huge body, it would seem 115 times larger than our Sun in the sky, and we'd be burnt to a crisp in seconds by its glowing hot accretion disk. At this point, black holes become so large that stars seem ridiculously tiny compared to them. The galaxy Cygnus A has a supermassive black hole with 2.5 billion solar masses and 14.7 billion kilometers wide, which would mean that if it took the place of our Sun, it would swallow all the planets and stretch halfway to the edge of our solar system.
Yeah, we can see
It's devouring
oh yeah, okay. Let's go.
so much mass and material that it churns its disk into a kind of magnetic funnel, spewing gas out, making tremendous radio lobes towering over the galaxy 500,000 light-years in diameter. That's 2.5 Milky Ways wide. Another pretty large supermassive black hole sits in the galaxy Messier 87. It has 6.5 billion solar masses and was the first black hole we got an actual photo of, or rather of the glowing gas around the edge of a menacing shadow.
Oh my god.
This sphere of darkness is so large that it covers our entire solar system. And yet, there is a scale even above these kinds of objects. Ultramassive black holes. Now we reach the most massive black holes, perhaps the largest single bodies that will ever exist.
And for me it's interesting. Why all this exists? I don't understand. It's maybe philosophical question, maybe it's a stupid question, but it's interesting for me why all this exists. It's all exists just for existing, just for being on this space, in this space everywhere. And I'm trying to understand meaning of our life, yeah, why we are here, to be useful for somebody, to have joy from our life, yeah, to be just happy. I want to understand this. And when we are talking about universe and why all this exists, I'm starting to understand what we are so small, and how much, which part we have on this planet. I mean, what is our role? And black holes, why they need to this? For me, it's mind-blowing. Oh my gosh. It's very interesting. And I will be glad to discuss with you and read your opinions about this, because it's very great, interesting. I cannot say it's great because it's a really interesting question for me. Because yeah, your opinion is always important for me. Yeah, let's continue.
These black holes have eaten so much that they've grown to tens of billions of solar masses, their gravity the engine for a quasar, an accretion disk shining brighter than thousands of galaxies full of stars. So massive that they deserve a title of their own: ultramassive black holes. The ultramassive black hole at the center of galaxy OJ287 is 18 billion solar masses. It's so big that it has a supermassive black hole nearly 40 times larger than Sagittarius A star orbiting it. This thing defies imagination and is really hard to compare to anything. It can comfortably fit 3 solar systems side by side inside of it. Let's end this insane competition and get to the King of Kings. Ton 618, a black hole that we can observe consuming galaxies worth of matter, is shining with the brightness of 100 trillion stars, visible from 18 billion light-years away. It has an incredible 66 billion solar masses, a black hole so large that it would take light a week to reach the singularity after crossing the event horizon. About 11 solar systems could sit inside of it, side by side. It may very well be the largest single body in the universe, but in reality, it's probably even larger. Since Ton 618 is so far away, we only see what it looked like 10 billion years ago. In any case, black holes are scary and mysterious and gigantic. They'll be here after everything else dies and growing larger and larger.
I want to say what, of course, after such videos, you will believe in everything, what's everything in this life possible. Yeah, you will believe in aliens also. Of course, you will believe because we don't know a lot of things. We know nothing about this universe. We don't know even our planet very well. I mean about ocean. Come on. And we are talking about stars, which we cannot, we have a really long distance between us. And yeah, maybe we are just experiment for somebody. Who knows, who knows? For me, it's very interesting to think about this. Yeah. And maybe I should watch a documentary video about how it say in English, UFO, yeah? UFO, am I right? Meaning, what unidentified flying object. I want to listen how I must to say it.
Unidentified flying object.
Unidentified flying object. Yeah. Okay, maybe I should watch a documentary movie about UFO. I think it will be very interesting to watch.
Okay, now let's do the trip again. From the smallest possible black hole all the way up to the largest.
Okay.
Let's try something new today. We can call it Behind the Lies, a short behind-the-scenes bit about the necessary inaccuracies in this video, because it's not really actually possible to rank black holes like trading cards. How so? Well, while we've catalogued millions of stars, we really only have good data on a couple of dozen black holes. That's because black hole gazing wasn't really a thing until 50 years ago, and technically still isn't because we can't see black holes. We can only derive their properties from studying their gravitational effects on the matter around them, like the orbit of stars that come close to them.
Wow, you should very well know and knew about gravitation in those places which you trying to understand. It's interesting way of searching black holes.
This effect depends on the mass of the black hole, which we can approximate at the most basic level with Kepler's laws.
Yes.
But this comes with huge uncertainties and error bars.
Cygnus, oh my gosh, it's difficult for reading to me.
Then we have to convert mass to size next, which brings new uncertainties. For example, we calculated the radius from the mass using the Schwarzschild equation, which for the sake of simplicity assumes black holes are perfectly round and don't spin, a kind of black hole that doesn't really exist. The reality is that physics on these scales is a bit fuzzy. So some of the black holes we talked about here may be way smaller or way bigger. We just don't know for sure. We shimmied around this problem by comparing different sources with different kinds of values and using different mass calculations to arrive at a standardized list that allowed us to be as accurate as humanly possible. You can look at all of this in our source doc. As a result, this script was written with the tears of experts we drove crazy with our obsession for the best values they could live with. In this process, tons of stuff got cut and didn't make it into the final video. But luckily, we found a way to not waste all of it. We've created a lot of black hole merch, spanning the whole range from somewhat bonkers to more serious. This way, we get to explore a topic from different angles, and you get to continue having fun with black holes after this video ends.
Okay, I get it, and this video was incredible, unbelievable. It's difficult to imagine for me. We can't see them. We can't, it's difficult to find them, and that's why maybe it's difficult to speak me about them. Of course, it's just a joke, but I will be glad to read your opinion, because I know in our community a lot of smart people. You are all smart for me, of course, and I will be glad to read your opinions. For me, it will be very interesting to know what do you think about aliens, UFO, and also I will be glad to read your opinion about black holes, because this video about a black hole. And yeah, thank you for having me. Thank you for supporting me. You can also leave a like and subscribe to me, and find my Patreon and be my patrons. And yes, of course, see you next time.